Probably everybody can see my screen now. Okay. Um, well, hi all. My name is Luis Sanchez. I currently work at Coventry University in the Sigma Statistics and Math Support Center. And well, in this space, I'll try to discuss our own experiences with regards to AI and a possible future implementation in our support center. The first thing that I would like to start saying is that, well, we are on the brink of an revolution in higher education, and AI is at the forefront. It's not just about automation, it's about personalization, engagement, and unlocking the full potential of every learner. So in this case, AI is enhancing our teaching and learning experiences in ways we never imagined, sometimes whether we like it or not. But for the sake of this talk, I'll be focusing on how AI and chatbots could transform the maths and stats support landscape. As you know, AI can simplify complex statistical concepts, making them more accessible to students, which is one of the key things here. More specifically, well, I could say that AI tools like ChatGPT can deliver a personalized learning experience for students. And this is great because these AI tools can adapt to the particular needs of each student, something that it's more challenging for a human in certain scenarios. But well, let me emphasize something. And here we are not saying that these chatbots will substitute human tutors in these areas, but instead they will be helping them to deliver a better experience for students. And I think that's the key thing here. For example, in Sigma, as well, we aim to offer extra hour support, and a chatbot could potentially help with that. Basically, there is something related to that, for example, there's this concept, the Vygotsky zone of proximal development. Basically, it highlights the importance in getting timely help for any student in their learning process. And for example, a chatbot, as I mentioned, could help in that thing. However, well, we must be mindful of potential pitfalls and biases inherent to AI systems. But in this scenario, there are two main options for implementing these tools, and specifically with regard of maths and stat support. The first thing is, well, closed source and open source. Well, there are basically closed source and open source AI models. Particularly, well, I would like to talk about the tool that these models can offer, which is not the standard chat experience. And in this case, I'm talking about AI agents and personalized GPTs. But, well, we could ask why they are more useful than normal chatbots. Well, aside of making them answer in a particular way to the students, we can make them to use our own technical materials, mainly PDFs, to answer those questions. And in that regard, to avoid more vague and possibly wrong information to be delivered to the students. But well, in any case, I'll show you an example of this in a moment with live demo. And with regards to open source models, two great elements related to them are that we can run them locally. This offers more flexibility and control compared to more commercial options. Plus, well, we don't need to pay any fee for using them. And basically, this is a clever solution in times of austerity, like currently. And well, in any case, going back to privacy, our information remain in our own computers while using these models. And this means that companies like OpenAI won't use our data to train their own chatbots. but also we can do something that these models usually are bad at. Basically maths, reasoning, and well, and also improve their knowledge in stats. So essentially, we can retrain them to be good at maths and stats, and thus be better than the normal chatbots. And an example of this is, for example, the Lemma model, which is based on the Llama LLM, which does precisely that, be great at maths, or at least, well, that's the intention. But another great thing about this is that, well, given that these models are open source, we have full control of what they're doing, so they are less like a black box. But well, so how can we use these open source models? Well, to run them locally, we can use tools like LM Studio that greatly automatize their implementation. Unfortunately, well, you still need to have a bit higher than average knowledge on coding to actually implement them correctly. And well, there's an extra thing that probably could be the only disadvantage on this scenario, because, well, not everything is good, is that we need a more specialized hardware to run them properly, like beefy graphic cards and more powerful processors. But without further ado, let me show you two of the implementations that we are trying here at Sigma. So let me show you first my friend Sigma, and I'll let him to present himself. So let's see. So this is one of the implementations that we are trying to implement, to work here in Sigma. So this chatbot is personalized in a way that he can focus on answering in the most easier and more toned down way to the students, because, well, some of them are not very technical, and we are trying always to make our best to explain difficult concepts in a very down-to-earth ways. And for example, this chatbot is very good at that. So for example, let's ask him to explain to us, for example, what's a t-test in very simplified words. Let's see. And well, here is like trying its best to answer the question. There is another thing that I mentioned before, that in this case, we can also add our own knowledge and make it use only that knowledge. So I'll gonna show you another example. In this case, we're gonna use this other chatbot. But before that, let me show you very quickly. So in this case, I'm using all these materials to try to answer any type of question instead of the knowledge base that GPT has. So let's see if we can get a better answer. I'll try to ask it same thing as before. And let's see what's a difference with the other chatbot. So in this case, probably you're going to see that, well, it's trying to extract the information from the PDFs that I fit it with. And in this case, this information is from the PDF, so probably it's fairly similar, but at least we are well, not completely sure, but at least we have a greater or higher level of certainty that these answers will be based on real concepts, or that the concepts are actually correct. And the other thing that I would like to show you is our own implementation on open source models. Currently, we're working on our own local version of these tools. So in this case, well, the interface of our chatbot is a bit well, it's a bit rough, but for now, well, it's just a proof of concept. And in this case, I'm executing everything from my computer and using an open source model. So let's test it very quickly. So in this case, let's, well, as you can see, in this case, our model, which in this case is a llama model, which is an open source model, is trying also to answer our questions. Let me ask it the first same question as before. Let's say, okay. Let's see, what can we get? In this case, well, well, here it is. As a difference with the chat GPT that I used before, currently, well, this thing is still using the knowledge base included with the llama model, but as the next step in our implementation, we're going to try to add the ability to read PDFs and to basically use only that information. But for now, in our local implementation, this is the state in which we are. But, well, basically, for now, well, this is our idea on how we can help ourselves and our community of students to get support. And as I mentioned, we are not trying to substitute any real life tutor. We are just trying to add an additional level of help to our students, because in our center, we usually experience a high demand for certain periods. And these tools could help us at least to be sure that even if the human tutors cannot attend everyone in one particular day, at least the students will get at first, well, certain amount of help, and then, well, we can complement that. And that's why we are—
1 minute, Luis.
Yeah.
1 minute.
Thank you. And we are trying to be sure that they are getting the best help possible. But, well, basically, this is for now what I want to show you. And, well, thanks a lot for the attention. If you have any questions, I gladly can try to answer them. Thank you.
Brilliant. Thanks, Luis, and a virtual or real round of applause there for kicking this session off. Thank you, and fascinating to kind of see how you're implementing that through Sigma. First question comes from Alistair, which is kind of highlights sort of a very kind of key issue that we know exists, that generative AI frequently gives incorrect explanations or calculations. So even with a retrained system, how do you ensure students are able to use this system critically? So, you know, this whole basis of it's a great tool, but you have to know what you're doing. How do we help ensure students know what they're doing with these tools if they're relying upon them?
Well, one of the things is, well, when we are building these models, we are trying to put certain rules, internal rules that the model needs to follow. Naturally, it's not perfect. And that's one of the things that we can do to basically make it more useful. The other thing is, well, obviously there's always good to introduce a very short overview on how this model works to the students. So I guess it needs to be a combination of, first of all, the guardrails that are in place inside the model, and also basically a small training or a small help to the students on how to use these tools. So I guess that's a way to avoid these type of things and to be sure that everybody is getting the best results possible. Yep.
And I think that leads quite nicely on to the question that James is asking about. Clearly the extent of training is really quite key to try and mitigate or minimize some of the errors. We'll never eliminate them, but how many staff have been involved in the kind of setup and training? Could you say a little bit more about what that sort of process is?
Well, currently we are, I'm working with one of my colleagues, Dr. Alan Owen, and right now we are the ones that are more involved in this. In the first stage, we want to make these type of implementations work for us, and basically we're going to start testing this with us, and then once we are make sure that everything looks fine, the next step will be to start rolling out this in our center, limited to our center. And the idea is that if we just make it available in our center, we can help the students to learn how to use it without any type of control. For example, if the student want to use it in their homes, well, we won't probably have the enough knowledge to make it work properly. So that's what we are trying to do first, to implement it in our center with our supervision. And then if we see that this thing is working fairly reasonable, we would try to proceed with next steps. Yep.
Anna's asked the follow-on kind of question, or question that I think is a follow-on to that. That Luis, when you kind of mentioned early on that one of the things you were wary of was sort of training these tools to, and the training that we do will make them better. Is this a kind of a sort of secure shell version in the sense that the data is not shared with OpenAI, or is this actually kind of being used to improve the mathematical aspects of OpenAI, which I think is the direction of travel they're very keen to go in, looking at some of their messaging?
Yeah, well, the idea is basically to avoid to share sensitive materials with OpenAI, especially with our open source models. Obviously, we know that using ChatGPT, we are exposed to that. And one of the things is, well, okay, we understand that probably ChatGPT uses this to improve the model, but given the current regulations in place, we don't want to avoid those regulations, and we want to be sure that the information is secure in our own local servers, and also because, well, we don't want to expose our own materials to probably unwanted sources. So that's one of the reasons to implement this locally, and also because, well, as I mentioned, we want to be sure that we know exactly how these models work, and because they are open source, we can actually see some of the algorithms inside these models, which we cannot know in closed source alternatives like in OpenAI, and also the cost as well. So currently, well, there is a cost involved in the closed source options, and with our open source implementations, we almost have the same level of power in terms of reasoning of these models. So I guess it's a fairly good starting point. I'm not saying that this is perfect, but basically, yeah, that would be my answer.
Yeah, and I think that's sort of an interesting point around the kind of the costing structure when you start to use the more kind of custom build. At the moment, that's not there with the monthly subscription that you see. but kind of clearly with every set of inputs and outputs with the tokens, that could quickly scale across an
Yeah.
institution. Also, I think interestingly, environmental costs, and that perhaps then ties in with the final question that I'll ask from Manish, which is, you obviously spoke about using GPT-4 Omni
Mm-hmm.
versus Llama, and Llama being kind of open source. What is kind of quickly is your take on the different levels of mathematical performance in those two tools? The sort of paid for version, and then you've got open source, which is Meta's sort of Llama offer.
Well, the difference, like for what I can see and for my knowledge, my current knowledge on the topic is that, for example, GPT-4o, it's good at stats, but it's got a lot of problems in maths reasoning. And this is not the fault of the model itself, it's just how the actual model works. And it's basically, it's hard for these models to actually be very good at maths, because how the models work, basically they are predicting the same word that it's trying, that could become next, but this approach doesn't work necessarily in maths. And the open source implementations like Llama are better in the sense that everybody can take them and can retrain them to be better at maths. For example, there's a lot of work going on right now in that regard. So, for example, I mentioned a model called Lemma that in this case seems to be promising, but it's still a work in progress. But this is not just the only project, so there are more. But I would like to say that I guess the future of at least maths and stats in science is leaning towards open source models, even if we have to run them probably in with the help of commercial solutions like Azure from Microsoft, but still they are open source models. And I guess that's probably the future for academic implementations of this technology. Yep.
Brilliant. Thanks, Lewis. And
Yep.
I think that's kind of an interesting debate, given if you look at the videos of how OpenAI was launched, GPT-4 Omni, I think it had that sort of parent and a child learning mathematics. There was some trigonometry going on, so you can see where they're trying to sort of take this direction of travel as them becoming tutors. I think that was fantastic. I think a quick round of applause again for Lewis for kicking us off.